Okay, thank you everybody for joining. This is Sam. Today we're going to be doing a monthly webinar series, and the topic of discussion is NCache architecture. I have one of my colleagues, Cal Ali, with me from our technology team. We're going to be talking about what NCache is, how it helps you with performance and scalability challenges, what the architecture actually looks like, what are the different ways to use NCache, and what are some of the important features of the product. Um, by the time we're done with this webinar, you should be able to understand what NCache is and how it would fit into your environment. During the presentation, if you have any questions, please feel free to ask us any questions on the right or the left-hand pane of your meeting window. There is a question and answer Q&A section. You can just go ahead and type your questions, and I will try my best to ask your questions during this webinar. Once again, Cal is going to be presenting. Any questions, feel free to ask us any questions, and we'll take it from there. With that being said, Cal, over to you now.
All right, thank you, Sam. Hey guys, so my name is Cal, and I'll be presenting today's webinar. As Sam just mentioned, you can ask any questions in between. And in the meantime, while I do the quick intro, if some of you could quickly confirm that you're able to hear and see me and Sam just fine. I'm also presenting my screen right now. So please let me know with a confirmation that you're able to see and hear everything. Okay guys, so in this webinar, as Sam just mentioned, we will be talking about what NCache is basically, what is the architecture, how it works, how it can be plugged into your environment to actually help your applications increase their performance and make sure that they become scalable, and also to make sure that your whole environment it can be referred to as a reliable environment. So that is the agenda for today's webinar. Sam, are there any confirmations yet?
You know what? I don't see anything yet.
All right. Okay.
Either everybody can hear us or nobody can hear us. Yeah, it's one or the other.
Could be the right.
Hey guys, could anybody confirm that you're able to hear us?
Okay. I think we should start then.
Yeah, please continue.
All right, guys. So let's talk about the actual scalability problem. So basically, within different environments, your application tier is usually very scalable. You have basically, let's say for example, you have a web farm that is sitting behind a load balancer. So in that web farm, you have web servers which could be hosting your web applications. They could also be hosting some other sort of applications, some front-end applications, or there could be some servers which are hosting some servers with services running on them which are supporting these web applications. So you could have a very big web farm sitting behind a load balancer, and they could be handling the requests that are coming in. So this tier, it's usually very scalable. You can, if you notice that you have more load coming in, you can actually add more servers here. And as you add more number of servers here, they would be able to handle more load that's coming in. So your total capacity actually increases in those areas. So the actual issue or the actual bottleneck lies where these applications that are deployed on these web farms, for example, have to get in touch with a backend data source. This data source could be a database or any other sort of mainframe data, and that's where the actual issue lies. So for example, your application could be referring to some sort of reference data or some sort of static data, and that's when you notice that after it hits its capacity, the database actually starts to choke down. And generally, as we all know, databases are slow. They tend to choke under high transactional load, and they're not very scalable. So that's where the issue lies. So if your applications are getting data and they're fetching data from the database, as soon as the database hits its maximum capacity, it is going to start delaying on the responses. And that's where your applications start to see delays in their requests. And in turn, your clients or your customers who are accessing your applications, they start to see an effect on their daily usage. So that's when you start to have a business impact within your application. This is usually not acceptable, that your applications start to take more time as you have more load increasing. So that's where the actual issue is, that you need to have an environment which can which you can scale out as you have more load coming in, so that your user experience continues, it's in a consistent way, and your applications do not see any sort of issues. Instead of web forms, you could also have web gardens. So within your application servers, you could have multiple instances or multiple worker processes running the same application, and you could actually use those servers to their maximum capacity. But again, the actual issue lies where these have to get in touch with a backend data source such as a database. So in such scenarios, in such situations, some organizations or companies, if they plan to move, or they sometimes actually do move towards a NoSQL database, because they're becoming a lot popular today. We actually have a product ourselves, which is NASDB, which is a NoSQL database basically. So for this, the NoSQL database in such a scenario may not be the optimum approach, because what a NoSQL database requires is that you need to have your application re-architectured or redesigned to be able to talk to be able to talk to these NoSQL databases, so that they can actually get data from it. Another thing is that these databases cannot be used all the time. So according to the logic of the application, they cannot be used at all times. That's another downside to it. And thirdly is that you also have to recreate and re-architecture your data according to those things. So there's a lot of work that's required if you're trying to move away from a situation where your database is becoming the source of contention, or it's become the bottleneck. So to actually handle this, a more optimum or better approach would be to have a distributed cache. And how it makes your environment better, I'm going to talk about it on this slide right here. So you can see this slide right here, and NCache is a distributed cache, as I mentioned earlier, and this is just an example for that. So you have your applications deployed on these servers. This could be your web farm, where you have multiple applications deployed, and they're sitting behind a load balancer. So again, as mentioned previously, this is an already a very scalable tier. You can add more servers behind the load balancer, and the load balancer would reroute all the requests that are coming in and make sure that all the servers within that tier are handling equal amount of requests, and they're actually increasing the capacity of the total environment. So in this case, the cache, which is a distributed cache, could sit right in between your database and your application tier. And what it does is it basically takes in the request. Instead of the request going to the database, now you're requesting the cache. It is going to be faster than a database, and let me explain how that works. So basically, this in-memory distributed cache, as the name suggests, all the data is present within the memory. So it's obviously faster. With databases, the data is present on disk, so it's slower and as compared to an in-memory situation right here. Databases generally are very good for storage, but when you have to scale out your applications, or when you have more load that's coming in, that's when they start to have issues within them. So in this case right here, you have a caching tier which is hosting your clustered cache. This clustered cache is logically a single unit, but underneath you have multiple servers hosting this. And now, not just your application tier, your caching tier is also very scalable. So you can see that this environment right here, it's linearly scalable. You can add as many servers here as you want. As you see that there's more load coming in onto your applications, you add more servers to your web farm, and now you can also add more servers in your caching tier. So once you do that, it actually increases the capacity of the cache, and not just in terms of the total data that your cache can store, but also in terms of the total requests that your caching tier can now handle. We generally recommend caching most of your reference data. As much as you can, you should add it to the cache, and that would save your application's trips to the database. So now your application would be getting it from a faster source. That's going to be a distributed cache, such as NCache right here. So in this diagram, it's showing as you can make the cache, such as NCache, your sole source for data. So your 100% traffic could go right to NCache, and then from there, if required, it can go to a backend data source such as a database as well. And that just shows this, that NCache has data access layer providing features through which you can actually make sure that if the cache does not have that data, it is going to fetch that data from a backend data source. And if you want to write the data not just into your cache, but also into a backend data source, we have providers through which you can actually achieve just that. So NCache could become your source for data as well, but you also have the option to make direct calls if that's what's required. So generally what we recommend is that if you're getting data from a database, you fetch it from the database, and then you also make a call to the cache to actually add it there as well.
Any questions at this point, guys? I just wanted to take a minute out and see if there are any questions, because Cal has shared some very good information up until this point. I just wanted to make sure that conceptually we're with him. Any questions? I guess there are no questions. Please continue, Cal.
All right, thank you, Sam. Okay, guys. So generally, again, the recommendation is to cache as most amount of data as possible. The data types can be divided into two. So one could be your static data or reference data, which your application refers to and which does not basically change a lot. And then you could also have transactional data. So you could cache your transactional data as well within the cache. So basically what happens is now your application is getting data from a faster source, that is NCache, so it would automatically start to see performance improving within your application. And even if the cache does not have that data, it's going to be fetched from a backend data source, and it's also going to be added into the cache and returned to your application. So in this case, all subsequent calls for that specific data would be handled by NCache. So first call may take some more time, only because it's a call to the database, but otherwise all subsequent calls would be pretty fast, and they would show quite great results for your application. So all of this makes sure that your applications are working in a pretty fast manner, in a pretty reliable manner. And let me talk about reliability now. So as mentioned earlier, databases are a single point of failure. You may have a replication on any one of the servers, but it's again, it's only a single source which is handling all of this. In this case, the cache is distributed on multiple servers. There are multiple servers pooling in their memory resources as well as computational resources. So they actually help in making this scenario reliable as well. So if one of the server goes down from here, so let's say one of the server goes down, it does not affect the complete cache. Your cache would continue to work just fine. And within NCache, we have topologies through which you can maintain replications on multiple servers. So one of the server goes down, your data is actually not lost. Clients actually fail over their connections, and the cluster actually recovers automatically. So in this case, it's a very reliable environment. If one of the server goes down, it is not a single point of failure. Your application will continue to work just fine. Even in the case for data, it is going to be, it's going to remain there and basically not be lost. Thirdly, your complete cache makes your environment very scalable. So now, as I mentioned earlier, you can increase the number of web servers within your web farm, and now you can also increase the number of servers within your cache to make them increase their capacity basically enough to be able to handle all the load that's coming in from the applications. So with this, you have a very scalable environment, you have a very reliable environment, and you have a very environment which is performing pretty fast as compared to its previous deployments. These servers right here, these are very inexpensive servers. There's NCache is supported in all Windows environments. So these are very inexpensive servers which pool in their memory resources as well as computational power. So they actually make your environment very stable in this case. Okay, so going forward, these are some of the scalability numbers. So as I mentioned earlier, as you increase the total number of servers within your application, they within your caching tier, they actually increase the capacity and the total number of transactions can be done. So transactions can be broken down into two. They can be reads as well as writes. So if you look at this graph right here, in this case we have two servers right here. So if we move from 2 servers to 4 servers, we actually see that the total number of reads increases from 50,000 to 96,000, which is almost double to what it was. And same cases for a number of writes. So writes are at 32,000 right here, but after adding 2 more servers, they're up to 64,000. So as mentioned earlier, it increases your capacity in the total number of transactions. These are some just general numbers which are done through our internal testing with 1 kilobyte average size object. I have complete benchmarks for different topologies of NCache that we're going to talk about later on. So while I talk about them, I'm going to show you those numbers as well, so that they can actually give you some further details as to how NCache can improve your environment. So going forward, there are 3 common uses of NCache, and I'm going to talk about them to actually give you what sort of use cases can actually help. Maybe they're similar to what you have in your environment, and how they can help you to make sure that your environment is performing well. It is in a scalable state, and then it's also very reliable. It's not. It does not have any sort of part where it is a single source, single point of failure, basically. So first one basically is application data sharing. So application data caching. So this can be anything that your application wants to cache. So this could be in your, for example, web application, or it could be a service that's supporting a web application. It could be some Windows service. It could be some Java application. So any application can basically connect to the cache and store data within it. And this data can be anything that's .NET permittable. So it could be, for example, images. It could be some sort of files. It could be strings. It could be any custom domain objects. It could be anything. It could be lists. So basically, you can store anything that your application wants within the cache. And this actually helps you so that, for example, if you have some sort of reference data, you can actually cache it within your environment. So once you cache it, you don't have to refer to the database to actually get it. For example, let me give you an example. It could be a product catalog. So it's something that does not change very often, but it is required quite often by your applications if it's, for example, an e-commerce application. So such data can definitely be cached into NCache, also transactional data that can actually help you. So to do this application data caching, you have to introduce the NCache API. It is very simple, it is very easy to use, and I'm going to show you a sample that shows you just that. So when you introduce that NCache API within your application, you can perform different operations on the cache. So they could be basic as adding and retrieving data from the cache, or there could be some advanced features that NCache offers. We have a lot of features that NCache offers through which you can actually perform different operations on the data that's existing within the cache. And if you want to fetch multiple items, you can actually do that as well. So it has a vast variety of features that you can actually use. They're present on our website. We have a complete list. You can actually go through it and see what you may be or your application may be requiring, and you can use NCache just for that scenario. So to use the NCache API, let me quickly jump onto a sample. So when you install NCache, it gives you a lot of samples within your installed directory. Let me actually show you that quickly. So this opened up right here. So this is my personal box. So if I go into the installed directory of NCache, that is in C, program files, and then NCache, and I go into samples, and then these are for different technologies. I'm going to go to .NET. So if I go to .NET, this is all the list of samples that I currently have. And so whenever you install NCache, it gives you a lot of samples through which you can actually see how you can work with NCache, how different features work, how they can actually help you. And maybe you can find some similarities between these samples and your actual live environments, and maybe you can use it there. So the two that I'm going to be working with is basic operations, which covers the basic API of NCache, and also for session caching, which shows you how you can configure NCache to be storing your sessions. So let's quickly jump onto the sample that we have opened up already here. So to use the NCache API, what you need to do is, first of all, you need to add the NCache references. There are these two right here. Once you've specified those, you can actually specify that you're going to be using these namespaces. And after that, you create a cache handle. So this is a cache handle through which you actually connect to a cache, and you can perform different operations on the cache. So this cache handle, let's actually highlight it so that we see whenever it gets used. So here, so if I want to, first of all, it needs to be initialized to start making operations onto the cache. So right here, you have this cache handle. So using this cache handle, I've just initialized it, and the minimum requirement is just passing the cache name. So you just provide it with a cache name, and that's about it. And the cache handle would now be initialized. So now this cache handle is initialized, and I can actually perform operations on the cache. So for example, if I want to add items to the cache, I can do a cache.add, provided with the key. This is a unique key. It's a string value, and then any .NET permittable object. So in this case, it's a customer class that I'm trying to add. So the minimum overload for this requires just the key and the actual value, and then you have further basically properties or that you may want to set for this certain item that you're adding within the cache. So these are further features that if I get time at the end, I will definitely talk about these as well. So the minimum one requires just the key and the actual value. So using this, you can add items to the cache. And once you have added items to the cache, you maybe want to fetch it. So if you want to fetch it, just use the same cache handle .get, provided with the key that was initially used to add it to the cache, and you would now have that item within your application. So using this, you can perform different operations. If you want to update an item, you can do a cache.insert call. If you want to delete an item from the cache, you can just use the same cache handle .delete, provided with the key, and using that, you can actually delete an item from the cache. And once you're done with all the work that you needed to with the cache, you can go ahead and dispose it off. So this was just to give you an idea of how easy it is to use the NCache API. It's a very simple and you can understand it pretty quickly, basically. So let's quickly jump back to the application data caching. So this, we've already talked about how you can use it. So this can be used in any, for example, web applications. ASP.NET web applications could be used in any services that are supporting this, or any Windows services, even Java applications. So you can use it in any sort of environment to actually cache applications data. Make sure that the data is closer to your application so that their operations are actually faster this time as compared to a database. So now your application can perform even faster in this case.
Cal, there are a couple questions. The first one is, how does the application connect to the cache cluster and know where the server nodes are located?
All right, so that's a very good question. So once you create a cache and you configure the clients for it, there are some configuration files that actually get updated within your application, within your environment. So let me quickly show you those. If I go into the same location, that is C program files, and then NCache, and then go into config folder, these configuration files actually help clients connect. So here, just this client.ncconf is the file that a client application actually uses to connect to a clustered cache. So if I quickly open this up right here, so these are the tags that actually get added and help an application connect to a cache. So for example, if in my application, if I refer to a cache name by my partition cache, the application is going to come into here and see where the cache is actually hosted. So here it would get an IP. Okay, it's present on 20.220.102. So that's how it knows where the cache is residing.
Okay, thank you. And there's another one. It says, can you share the detailed API guide also?
Okay, yes. So we have complete documentation present on our website. And if you go to here, go into product library, go into documentation. Then here you have the installation guide, and then you also have the programmer's guide that's present right here. It's for all editions. So just go to our website, go into resources and documentation. You have the programmer's guide present right here, which you can use. Okay, so
okay.
All right.
Perfect. Thank you very much. Please continue.
No problem. Okay, guys, so we talked about application data caching, how it can be used within your application, how simple the API is, how you can quickly use it and make different calls to your configured cache. So the second use case is ASP.NET and ASP.NET Core caching. So what that involves firstly is ASP.NET session state storage. So first of all, NCache has provided us a provider through which you can basically store your sessions within NCache. So your other options for storing sessions are in proc, and then within your applications process, and then the other one is using a state server, or you could use a database. So let me explain how NCache is better to be a provider as compared to these three. So first of all, with in proc session caching, you basically have to make sure that the same request from the same client actually comes to the exact same server, because that's where the session is lying. So you need to have sticky sessions, and you need to have sticky load balancing for this case. So if your a certain server is getting more requests, it may start to choke down, because other servers may not be getting those requests because you have sticky load balancing. So that's one downside to in-proc caching. And then also in the case that, for example, if that web server goes down, your data for that data that was present within those sessions is actually lost. Your applications your users actually lose their sessions, and in this case, sessions is generally very important data, something that usually people do not want to lose or do not want to have any sort of issues with them. So that's a big issue with in-proc session caching in this case. Sam?
Cal, yeah, there's another question, and actually there are a couple of questions regarding the same thing. And the question is, can you suggest any more material if they want to learn more about distributed caching? So I think it's perhaps has to do with information on our website and information in general.
Okay, so for this, I have the details for the requester. I think I can share some links on his email address, and maybe he can use those. So after this webinar, I'm definitely going to share all the different resources. There may be a few of them, so I can share them over an email, and you can use those.
Perfect, thank you.
All right, no problem. Okay, guys. So yes, I was talking about the different options that you have for session storing. So first one we talked about was in proc session caching. So basically, within proc, I mentioned that it's a single point of failure. You need to have sticky load balancing, as well as your requests only come to a single server if they are from the same client. So that's one issue with it. The second is the session state storage provider. So through that, basically, it's again a single point of failure. It's a single server that's hosting your sessions. If it goes down, it actually the complete data for sessions is actually lost. It may start to get choked down under high load that's coming in. So if you have a lot of requests that are coming in, if you have a lot of users currently, for example, on your website, it may start to choke down. Your applications your users may start to see some degradation in their total response time that they were generally getting, but now it's quite delayed. So it may have a business impact, which is not acceptable at all. The third one is basically putting it in databases. We've already talked about how databases can be a point of contention. They're not scalable, so they're a single point of failure, and they tend to choke under high load. So keeping all of these things in mind actually make sure lets us know that databases are not an optimum approach at this point, because if you have more load coming in, they may start to see degradation in their performance. If you have if that server actually goes down, it may be a single point of failure. Your complete data for those sessions may also be lost. So these are some of the situations that you may move you away from such a provider. So this is where NCache comes in, and NCache actually handles all these scenarios. So as I mentioned earlier, NCache is distributed in nature. So since it's distributed in nature, it is not a single point of failure. You have multiple servers. If one of the server goes down, it does not mean your whole cache goes down. And then within the cache, we have replications on multiple servers. So one server's data may be replicated onto another server. So if this server actually goes down, this data can be retrieved right from here. So your data is not lost. It is not a single point of failure. And now in this way, you actually don't have to worry about at least this part. Secondly, it does not choke under high load. If you have more load that's coming in, you can actually increase the total number of servers that are hosting your clustered cache. And now this tier is actually scalable now. So using this, you can actually match it up to the total requests that are coming in, and have your users get a consistent experience with your application. So that's another plus point for this. And everything is in memory, for example, is in comparison to database. So all the sessions are kept within the memory. It's obviously going to be a lot faster than a database. So having sessions being stored with NCache gets you all of these plus points. It is faster, it is more reliable because of data redundancy in multiple servers hosting this, and it is very scalable. You can scale it out according to number of users that are coming in, and it actually helps your whole overall experience of your application quite a lot. And the best part about this is that it's a no-code change option. You can actually just update your application's configuration file, and that's pretty much it. That's all that's required from you to have sessions being stored within NCache. So let me quickly show you this, and you can actually do this within 15 to 20 minutes, the whole cache creation process, and then also this configuring sessions within your application. And then you can actually test it out. You can see how NCache performs for you. You can perform failover tests. You can make one server go down and see how it generally affects your whole environment. So I have another sample opened up, that is the guest game sample, which is session storing, storing sessions with NCache. So as I mentioned earlier, it's a no-code change option. You only need to update your application's configuration file. So I'm in that web config right now. There are only 3 steps required here. First one is to actually register your assembly right here. And this assembly is the alachisolve.ncache.session-store provider. You can actually copy this complete code from here, this complete tag, from one of the samples, and put it in your application. You don't need to actually type it there as well. So you have a complete working sample within your own directory. You can actually use it there. So if you scroll down right here, first we've added the session assembly, we've referenced it. And the second thing here is that you add the session state tag. So this session state tag, again, you can copy this from the sample and put it in your application. So that is the second step. You add the session state tag, where you specify that this is going to be a custom mode, and you specify NCache to be storing your sessions. So that was it for step 2, and there are some further settings that you may want to change and you want to set according to your needs. The third thing that is required is just to make sure that your cache name is set to be correct. So currently it's set to my partition cache. For example, if I have a cache named demo cache, I may need to change it accordingly. So I can just change it demo cache, save this, and that's pretty much it that is required from my end. So now I have my applications all set and ready to store sessions within NCache. So that's how easy it was and fast it was to have this application storing sessions with NCache. Okay, so that's pretty much it about sessions and how NCache is a very good provider just for that.
Cal, there's a question.
Yeah.
And the question is NCache distributed as master slave or is it masterless? So I guess they were talking about the topology.
All right. So NCache does not have any sort of master slave or a majority rule concept. It is basically all the servers are working independently. If one of them goes down, it does not affect the complete cache. It continues to work just fine. It's a self-healing. It's basically the self-healing concept. I'm going to talk about those in the next slide in reference to each topology that NCache has. So definitely NCache does not have any of those. If one of the server goes down, it does not actually affect your whole cache.
Okay, and there's another one. And the question is, if we are experiencing slow performance using NCache sessions, can NCache help?
Okay. For this, if you're currently using it, there are different things that you can work around within your session. You can actually check how many servers you have, what is the load that's coming in. Maybe your cache servers are actually being choked. You can add more servers to increase that capacity. As I mentioned earlier, it's very scalable. So you can add more servers to have more servers hosting your clustered cache, and that would increase the total capacity of the cache in the total transactions that it can do for example, per second. And then your topology could also matter in that case. So generally, we recommend partition of replica to be used for sessions because it's reliable as well as very scalable. So there are a lot of things that you can actually check within your environment to make sure that NCache is performing in the most optimum way for your specific use case.
I think, Cal, the question was around if they are not using a distributed caching solution, so perhaps a sticky session versus something like NCache.
Right, I thought it was that they're having issues with NCache. All right, so if they're using sticky sessions, as I mentioned earlier, if you have sticky sessions, your load that's coming in from your applications, it is onto your application servers. It's not actually completely divided because the request that was previously seen to a certain server would be coming right to that same server. So first of all, your load does not get divided. There may be a scenario where one of your servers may actually start to choke. And secondly, it's a single point of failure. If that server goes down, there's no replication being maintained for those sessions or for that data, and that data would actually be lost. If that server goes down, your user data for that server would actually completely be lost. And thirdly, basically, since you have the load is coming onto specific servers only, you're not using the complete capacity of your environment. It may start to get show slow performance overall in general, even though that you have a lot of servers, but it may not have that same effect as it would in proc.
Okay, perfect. Thank you.
All right, no problem. Okay, so we've talked about session state storage with NCache. We've talked about how NCache can make it very reliable and very scalable and make sure that your performance is very good with NCache. Secondly, we have ASP.NET View State Caching provider as well. So this is pre-MVC, where for example, if you have a lot of widgets or a lot of controls within your application, a view state actually gets generated, which is a client-side management protocol. So through that, basically, it's not used in the server end, but it's only used on the client end. But it was previously sent as a request and response. It's part of the same payload, and it would be sent as a request and received as a response as well. So because it's quite big in size, as you have more controls, more widgets, it actually grows in size a lot. So that could be taking a lot of your bandwidth that you're currently using. And for example, if you're deployed in Azure, that could be costing you in dollars. So since that whole bandwidth gets increased, the whole payload size is actually increased, the whole package is increased, it actually it takes more time, or it takes more time to be processed. So your overall performance may actually start to get degraded as you have the view state getting bigger and bigger. So in this case, what NCache does is NCache can use your basically it can use your view state on the server end. It can keep it cached within the cache, and it can send a small token, which is basically a GUID, onto the client end. So using that, only the view state would actually be saved on the server end. It does not need to have to travel all the way onto the client and then back again, because it's only required on the server end. So only that GUID would be sent, which is a unique key, which is used to store it within the cache as well. So now it's not part of your request and response payload, so it only stays in the server on the server end. So your complete size for that request is actually decreased, and also the response, it's faster, it's costing you less, for example, dollars if you're talking about bandwidth here. So NCache actually makes sure that it is it makes your performance improvements improves your performance quite a lot in this case. So through this, you can actually, and we already know about all the good things that NCache brings in, for example, reliability and then scalability. So using all of these, your environment can be in a pretty good state if you store your view states, if you have a lot of them within NCache. Next is ASP.NET output caching. So basically, this is for ASP.NET, and then for ASP.NET Core, you have response caching. So NCache provides for both of those. So in this case, for example, if you have sections or portions within your web page which may have some sort of static data or data that does not change very often, maybe it's a table. So for example, if you're showing a product catalog on your web page, it's data that does not change very often, but it has to be fetched from the database every single time. So every time you request your applications you have a request coming in from one of your customers, for example, it needs to get fetched from the database every single time. So doing a database call every single time may actually be costly, and depends that the data that you get, then you need to do some sort of processing on it, and then it needs to be displayed and sent back. So all of that combined together can actually take up a lot of time and have some bit of negative effect on the performance and generally the total response time. So if you can cache that, if you can cache those static data within the cache, they can be sent right back from the cache. So it's going to be a lot faster, as we talked about earlier about the contentions with database. It's going to be a lot faster if it's coming from the cache, and it can make sure that your application works in a pretty fast manner. So using this, basically you can even cache the entire page, or you can cache certain portions within the page which you know that are not going to be changing very often. And then we have some further features through which you can actually ensure that the data within the cache actually remains fresh as well. So using these can have a lot of good effects within your application. Generally, it's a no code change option, so you only need to update your application's configuration files, and that's pretty much it. Session storing is also provided for ASP.NET Core application. So if you have an ASP.NET Core application, you can actually store their sessions within NCache as well. And fourthly, we have implemented the iDistributor caching. So using that, you can actually implement it, use it within your environment, and use NCache as well on the back end. So these were the two use cases that NCache is mainly used for. Then there's a third one, which is runtime data sharing. So this can be, for example, if you have serverless apps which are talking to, which are basically need to have some sort of synchronization. Synchronizations can be done through either message passing or some sort of event notifications. So NCache can be used a medium just for that. We have the complete PubSub model implemented, through which you can actually, your applications which are publishers can actually publish a message onto NCache, and then NCache can send those messages to all the subscribers which have subscribed, for example, to that specific channel. So they can actually get the notifications or data or any other sort of messages from the NCache. So NCache can definitely be used as a medium just for that. And then we also have event notifications. So for example, if you your applications can get notified, for example, if a data gets added or if a certain key gets updated. So you have all these options available with NCache. We also have continuous query. So for example, you could set have a certain you set a query through which you have certain rows within the database. So any sort of update within those rows or within those rows within the database, any update can actually be sent as a notification to your application. So through this, you can actually have continuous query also implemented within your environment. So I've talked about the three main uses of NCache. You can, if you have any application that has similar scenarios, you can definitely use NCache with that. And we've talked about how it can make your overall experience very good. So let's talk about how NCache is a self-healing dynamic cluster. I think there was a question related to this part as well, and I'm going to talk about right that. So NCache ensures high availability. It makes sure 100% available uptime as long as you have one server up and running. It's 100% peer-to-peer architecture. So there's no single point of failure. There's no master, slave, or majority rule sort of concept within NCache. So all the servers are working independently, but if one of the server goes down, it does not affect the complete cache. We have replications maintained, and then we have internal logics through which it heals itself quickly, recovers from that loss, and continues to work just fine. So your applications do not see any sort of downtime. They continue to work just fine. Their requests actually get rerouted to the other servers in the cluster. You can add servers on the fly, and then you can remove servers on the fly. So that does not affect your cache. You do not need to stop the cache. Your cache can stay up and running. You can add a server, start it, it can join the cluster. You can actually remove a server on the fly as well. So whether a server gets removed through an unforeseen scenario or you do it manually, the cluster would recover from it just fine. It would continue to work just fine in this case as well. The connection failover support, that is, for example, from client to server and then from the servers in between, is built into it. So if there's any sort of server being moved out of the cluster, it is automatically detected by the client end as well as the server ends, and they fail over their connections automatically, and they start the recovery logic automatically. So in this case, you basically do not need to do any sort of retry logic within your own applications. It's done. Everything is done by the NCache client to server protocol. So all these configurations, they're dynamic. They get updated automatically as soon as you have, for example, new servers being added or servers being removed. So they actually get updated automatically. On the client end, the minimum requirement is knowing just about one server within the cluster, and once it joins, it actually gets a whole view of the cluster. So let's say, for example, that you have a client right here and you have your whole cache cluster right here. Once the client connects using even just a single IP, it gets information about the cluster. It gets the views about the cluster that, okay, this cluster has 3 servers, and it, depending on the topology, starts connecting to it or does not connect to it, depends on that. We're going to talk about the topologies just now after this. So NCache has 4 topologies. It has a mirrored cache, replicated cache, partition cache, and partition of replica cache. I'm going to talk about them one by one, but the most popular and most recommended one for different scenarios is partition of replica cache.
Cal, before you begin on topologies, there are a couple questions. So the first question I have for you is, can we have sharding with NCache, or is it just supports replication?
So basically, data is divided automatically. There's a distribution map through which the data actually gets divided automatically. And then we have features of, for example, tags and groups to which you can create logical collections within the cache and perform different operations on it. Even though that there are multiple items, for example, a customer could have hundreds of orders. They're added as separate items, but using those separate, you can actually create logical collections. So you can create those. The data division is done automatically within the cluster.
Then there is another question. What if we have different geographic locations? Can NCache form a cluster?
Okay, so generally what we recommend is that having all the servers within the cluster on the same network and even on the same site. But we do have a feature of NCache bridge, so you can make sure that 2 different sites, for example, 2 different cache clusters, can remain in sync with each other if they're active in an active passive scenario or if they're both active. And I'm going to talk about that after these topologies.
Okay, one more, and the question is, can we have atomic write in a cluster?
Atomic write into the cluster?
Yes, in a cluster.
All right, so all the operations within the cache are actually atomic. When you're about to add something on a certain key, it actually locks it. So any operation being performed on a certain item is atomic. They're basically in a first come first serve. So as soon as operations are being received, they actually get an ID and they get executed on the cache based on that ID. So whenever the first operation comes, it's going to be performed in the same order.
Okay, that's it for now. Please continue.
All right, thank you. Okay, so we mentioned that there are 4 topologies. I'm going to talk about the first one, that is mirrored cache. It's a 2-node active passive scenario. If you look at this diagram right here, this is your cache cluster. You have two nodes. One is the active node and one is the passive or the backup node. All the clients have a connection to the active node only because it's designed in such a way. The operations, all sorts of updates, any operations being found on the active node actually get replicated onto the secondary node, which is the backup, in an async manner. So there's a queue that is actually being maintained. It is quite fast, but it's just that your client application does not have to wait for this replication. It performs the operation on the active server, and then it actually, the control gets returned to it. So in this case, if the active server goes down, the backup automatically comes up as the active one because it has detected that the active one has gone out of the cluster. Clients again also automatically detect that the active server has gone out. They fail over the connections to the newly active one, that is this server 2, and they continue to work just fine. Since the data was being replicated, there's no data loss, and basically your applications do not see any sort of downtime. They continue to work just fine. This is generally recommended for smaller configurations. There's a maximum limit of 2 server nodes here, but with other topologies, there's no limit to the total number of servers that you may want to have within your environment. Going forward, we also have the replicated cache. Actually, let's talk about the benchmark numbers. So for mirrored cache, if you go to the website that's right here, go into product, go into NCache, and then you have the benchmarks right here, NCache benchmarks. So if you go right here, these are the configurations with which they were initially tested, and this is one that we're talking about for for mirrored cache. So if you see right here, since it's only a 2 node, that's why we're seeing only this. So you can see that it's doing up to 26,000 reads and about 20,000 writes. So since your application only has to update on a single source, it's quite fast, and you can actually use it within your environment to have good performance. Okay, let's quickly jump back to the next topology, that is replicated cache. As the name suggests, the data is replicated among the servers that are currently present. So here, for example, you have 2 servers. You could have as many servers here as you want. There's no limitation. So in these 2 servers, they have a complete copy of the cache on each of them. So server 1 has 6 items and server 2 has 6 items. Any sort of updates within the cache are performed in a sync manner. So any update on server 1 has to be performed in a sync manner on server 2. The client's connections are actually divided among all the server nodes. So in this case, 3 are connected on server 1 and 3 are connected on server 2. So using this, basically, their load is also divided among the servers that are currently working right now. So in this case, as you add more number of servers, the client requests actually get divided, and they have a complete copy of the data within your environment. It's a very good topology for reads because the requests are automatically divided, so the servers are not being choked out at any point. But for writes, it's the performance actually is not as good as the other topologies as you add more number of servers, because there are more sources that need to get updated with any sort of update. So in this case, if one of the server goes down, the clients fail over the connection to the remaining servers present within the cluster. So as I mentioned earlier, once you initialize the cache within your application, the application actually gets a view through which it knows how many servers are currently present. So if it's connected one actually goes down, it has IPs of other servers through which it connects and continues to work just fine. So if you talk about the benchmark numbers for that, in this case, we can see that this is for replicated cache. So as you add number of servers from 1 to 2 and then from 2 to 3, you can see that the reads actually increase quite nicely. That's because the load is actually divided among all the servers. So it's quite fast, and each has its own copy of the cache. And then as you increase, you can see that writes actually go down because multiple sources need to get updated within that same call. So it's recommended for a more read intensive scenario. And if we go right here, let's jump back to the presentation. Here, the next one is partition cache. As the name suggests, the data is actually partitioned among the servers present within the cluster. So if you look at this diagram right here, the total data within the cache is 4 items. That's 1, 2, and then 3 and 4. They're divided among the 2 server nodes. The clients have a connection to all the server nodes within the cluster because the data is divided. They may want some item from server 2 and they may want some item from server 1. So that's why they have a connection to all the server nodes. They get a distribution map through which they know exactly where which item is present, so they automatically know where to put this request for. So through this, since the data is divided, their requests are also divided. And in this case, if one of these server goes down, the data on that server is actually lost because there is no replication being maintained. But on the other hand, this is a very scalable topology of NCache, both in terms of reads as well as writes. So as you keep adding more number of server nodes, the data actually gets divided and the requests automatically get divided as well. Since it's a single source, So you only need to update that very same source, and that's pretty much it. There's no replication being done, so it's quite fast. So if we look at the benchmark numbers for this topology, they are present right here. So this is for partition cache. You can see as you add more number of servers from 1 to 2, then 2 to 3, and so on, it has a linear increase in the total number of reads as well as writes. So it is a very scalable topology of NCache. It gives you great performance, but in terms of reliability, if that server actually goes down, the data on that server is actually lost. So that was it for partition cache. I'm going to talk about the next one, that is partition of replica. And as I mentioned earlier, it is the most recommended one and most popular one amongst all of our customers. So why is it popular? Because it takes the performance of a partition cache and then it adds reliability to it. So in this case, you can see it's quite similar to partition cache. The data is divided among the servers, but now there are 2 partitions within each server. One is the active and one is the backup. Through the backup, you can actually make a backup of one of the other servers. So if that server goes down, there's a backup maintained on one of the other servers. So data is not lost if one of the server goes down. But you have a linear increase in the total number of reads and total number of writes as you add more number of servers. So this gives you a pretty reliable environment, a very scalable environment. You can add as many servers here as you want. You can increase it according to your load that's coming in. And data is reliable because there are replications being maintained. One of the server goes down, it does not affect the complete cache. And the data is actually not lost as well. If one of the server goes down, the data from its backup present on one of the other servers actually gets to start redistributed among the servers. Clients get an updated distribution map through which they know, okay, this item was previously present on this server, which is now gone. Now it's present on this new server. So they continue to work just fine. Your applications do not see any sort of downtime. They continue to work just fine. And with this, the replication from the active partition onto a backup partition can be in an async manner or a sync manner, and that's something that's configurable. You can do it within your when you're creating your cache, and through that you can actually make sure. So async is generally faster because your application does not have to wait. But then if you want that to be a part, you can actually make it sync, something that you configure when you're creating the cache. Let's quickly look at the benchmark numbers for this. So if you scroll right down on this page, you have the benchmark numbers for the partition of replica cache. So you can see that as you add more number of servers, there's a linear increase in the total number of reads as well as total number of writes. So this gives you a very scalable environment within your application. You can add as many servers here as you want to continue using your application. The second is, this is for synchronous. So as you add more number of servers, you can see that the writes actually go a little bit down, but that's only because it has to wait for the backup to get updated as well. With async, it's done in a background process. It's still pretty fast, but your application does not actually wait for it. So let's quickly jump back to the presentation right here. We've talked about the 4 topologies: mirrored cache, partition cache, replicated cache, and partition of replica cache. Again, partition of replica is the most recommended one. This diagram quickly basically shows you a view how it would be if you have 3 server nodes within the cluster. So server 1 has its backup on server 2, server 2 has its backup on server 3, and server 3 has a backup on server 1. So if any one of the server goes down, the data is not actually lost, the cache continues to work just fine as well. So I've talked about the 4 topologies, giving you some bit of details how you can configure for different type of data that you may have within your application, different use cases. So it may help you. So the first thing that I want to talk about here is one of the features of NCache, that is client cache. So this is a performance enhancement feature. So first of all, client cache is basically a local cache that's present on the web boxes right here. It actually keeps itself synchronized with the clustered cache. So through this, you can actually have it as in proc or out proc. So using this, your client cache can remain in sync with the clustered cache. It's basically a subset of the clustered cache's data. So so any sort of updates within the clustered cache get propagated onto the client cache, and then any updates on the client cache get propagated onto the clustered cache. So in this case, it remains in sync. So now when your application is requesting for some data, it can find it from a local source that's present on the same box. If it's in proc, it's going to be even faster, but if it's out proc, it's still going to be a lot faster than your data traveling over the network. So what this does is, the cache already basically limits the total number of database trips, a clustered cache. But now with an in proc cache or an out proc cache, it actually limits the total number of operations that you have to do outside of your box. So all these operations, if your application requests for some data that's present within the client cache, is actually resolved from the very same box. So your request does not even need to leave your machine. It's going to be present, the data is going to be present right there and then. So it's going to have a lot of improvements within your application in terms of performance. It's a no code change option. It's just a feature that you enable or disable, and based on that you can actually test it, see how it works, and actually keep it implemented within your environment as well. It is generally recommended for a read intensive scenario, because if you have writes, then you have two sources which are going to get updated with any sort of updates. But in terms of reads, we just generally recommended for 70% above reads, and that's where you'll start to see the real performance. So you could have a separate cache for your reference data or static data, and have a client cache configured just for it. So based on that, your application can see quite some bit of improvements with a client cache configured within. The second thing that I want to talk about is the WAN replication, multi-data center support. There was one question around this as well. Yeah, Sam, a question?
No, I actually just wanted to inform you that we're at a 5-minute marker, so we have to wrap up in 5 minutes.
This is just the last thing I'm going to cover, and then we can come back to any questions.
Okay.
All right. So this is the WAN replication of the cache. So for example, if you have two different sites, generally we recommend, and it is highly actually recommended, to keep all the servers within the same data center, within the same network as well. If you have two different data centers, you could have two different caches and have a bridge set up just like this on this diagram to keep both sites in sync. So for example, you could have a primary site, and then you could have a secondary site. Primary site can remain in sync with the secondary site by replicating all the operations using the bridge onto the secondary site. So this is an async replication. Through this, all the operations from the primary site would actually get replicated onto the secondary site. And if you have an active scenario, both sites are up and running. So you could have the bridge replicate from site 1 to site 2, and then from site 2 to site 1. Maybe you have a data center in New York, or you also have a data center in London. So keeping both of these data centers in sync with each other, you can use the bridge feature of NCache. That would actually make sure that you can keep both sites in sync. So guys, I think that's the end of the webinar. I have covered all the details. This is just an API overview that we have already gone through using the sample project. And no, this is the last slide. Sam?
Okay, very good. Any questions here, guys? I guess there are no more questions. Let me just go through the list once again.
Sure.
Okay, there is a question,
yeah.
And the question is NCache a key value database?
Yes, so basically everything within the cache is in a key value base. So key is actually unique, which you specify when you're adding data to the cache. If you remember during the API overview that I was giving on this basic operations, you actually specify a key when you're adding data to the cache. So for example, this is the cache, and I'm doing adding this item to the cache. This is the key that you specify. It's a unique string that you can use to add data to the cache.
Okay, and then there is another question, and the question is, can we implement WD patterns with NCache?
WET patterns?
WUD.
WUD. I think we do, but I may have to get a confirmation on that. I have your question and your email address as well. I can actually get back to you once I get the confirmation on this.
Okay, perfect. So let me just go to the list. Use case. With that being said, guys, thank you very much for your time. Give us a call if you have any questions, and we'll see you soon. Bye now.
All right. Thanks, guys. Have a nice day. Bye.